All right, so remember back to yesterday when we simplified square roots when they had an I. Okay, so this right here, that negative x, all right, so remember back to when we simplified radicals with negatives in them. The negatives we need to take out as an I first. So it should be like this, and then we can simplify that 125 down, okay? So we have to take the imaginary part out before we can simplify that down. So 125, that's going to be a 5 and a 25. Break that down to a 5 and a 5, and then remember we're looking for pairs because this is a square root, okay? This little number that's implied here is a 2. That's called the index. So you're looking for a number, a pair of numbers here since that's a 2. We'll work with cube roots and fourth roots later on, but that's why we're looking for 2. It's a square root. Okay? So the 5 comes out, we have the I, and then the square root 5 is in the radical still. Okay? That's how we do that first one. Second one, same kind of idea. I comes out, we got 128 x to the fourth, and then we're looking to break these things down. Now I know this one has a variable, so it's a little bit different. Let's do that 128 off to the side. So easiest thing, if you don't know what goes into 128 or a number, take out a 2 or a 3. Okay, so we take out a 2, we get a 64, and we just keep breaking that down by 2. So 32, 216, 8, and 8 is made up of 2 times 2 times 2. Okay, this is the easiest way to do it with a bunch of 2s. So we got a pair here, we got a pair here, we got a pair there, and then 1 goes back underneath there. So 2, 4, 8. We multiply those when we bring them out. And then we need a place for the variable here. 2 goes back underneath there, all right? And then x to the fourth, this is how we think about that. So that is x times x times x times x. There's 4 of them, right? Same kind of idea. We're looking for pairs. So how many pairs of x's can we get out of there? That's 2. We bring an x out for both of those. That gives you x squared. And that is what you got left on that one. All right, so this is your final answer for that one. Starts to look a little crazy with the variable and the I there, but you want to keep the number, the variable, then the I goes right next to the radical. All right, so this part here, factoring, this is a little bit of a preview for what's coming up in the next lessons, but we've kind of done this before. So in order to factor, you have to have everything on the same side. So this 2 needs to get moved over. All right? So x squared minus x minus 2 equals 0. And then this is where we set it up to make it look like a FOIL. We're pretty much undoing the FOIL here to see what we factor it out to. So x's go in the front. 2 numbers that multiply to a 2 and add to a negative 1. That would be a 2 and a 1. And in order to get these to add to a negative 1, the 2 is what has to be negative and the 1 has to be positive. And then that's factored. So I have gone through these before where we need to figure out what would make this equal to 0, what would make this equal to 0. So this is called the zero product property, which we'll hit again. So my answer from my first one here, that would be x equals 2. My answer from the second one here, that would be x equals negative 1. And those are the 2 solutions. So thinking back to what you did in the previous lesson, you could graph this. We'd take this function here, set it equal to 0, and graph it. And you would have x-intercepts of 2 and negative 1. All right. Last one, same kind of idea. We are going to solve this by factoring. In order to factor, we got to have everything on one side. So we're going to move that 16z over. And now this one is a little bit different since you don't have a number on the back end. This is when we factored using what's called the greatest common factor. So you look between this, and you ask yourself, what can you take out? The only thing we can take out from these would be the variable z. And when we do that, we're left with z minus 16 equals 0. And then we kind of do the same process we did up here. So we have to look at each individual piece. Can I plug in something here to make it a 0? Yes, I can just plug in 0. So that's z equals 0 for this one. And then what could I plug in for this one to make this 0? Well, that would be 16. So my two answers are 0 and 16. All right, that's solving by factoring. We'll hit that again in the next lesson. All right. So I went and looked back at some questions that I've had in the past just to kind of get an idea what you all might be looking for. So this section covers the homework questions from the previous lesson. So if there are no questions, you can skip over this section and start the lesson. Otherwise, we'll pay attention to these for a little bit. So 38 had a question with something going through the air, and the speed is 80 feet per second. This right here, that little v sub 0, that is where you plug in your initial speed, okay? So when I plug in 80 here, I get this function right here. And since you were supposed to solve by graphing these, all right, which you could at this point solve these by factoring. I just showed you how to do that. But since we're supposed to solve by graphing, this one's kind of a bear to graph. It's a little high up there with the numbers that you're working with. Okay, so graphing this, you do negative b, so that'd be negative 80 over 2 times a. So 80 over 32, you get 2.5. And it's actually not that bad when you start working with the numbers. So you get 2.5, okay, and that is up here. And the question was, when will the thing hit the ground? And if your maximum height is at 2.5, if you follow that path, okay, if this is 2.5 seconds, then this has got to be 2.5 seconds, which means we're going to hit the ground at 5 seconds, okay? If you are supposed to find how far out it hits the ground, then you're looking to find the intercepts here. You would have an intercept of this and an intercept of that, which that might take a little bit more work. You're going to have to factor and solve in order to get those. But I think the question was just looking for how long was the object in the air. Okay? And then number 40 was a similar scenario. You have this function here, then you had to either graph it, maybe find the maximum or minimum here. So you do negative b over 2a, plug that in, 100 over 32, we get 3.125. And when you plug that back into your function, you end up getting 6.2, or sorry, when you multiply that by 2, similar scenario, it's in the air for 6.25 seconds. So it looks like it was the same kind of idea there. Okay, so 32 is one that I've hit before. I can talk through that one real quick. So you FOIL it out. We take the 4 and we multiply first, outer, so that would be 24 minus 24i, inner, that's negative 6i, and left. That would be a positive 6i squared. And remember something that you might forget, I squared always turns to a negative 1. So wherever that I squared is attached to, you need to flip the sign, change it to a negative. Okay, and then just finish that out. So 24 minus 6 is 18, and we got minus 30i. We got to have it written standard form. It's got to be a plus bi when you're doing this. And then there's some other ones. If you see one, you can pause the video if you wanted to look at one of those. 49 and 50 are always ones that kind of stick with people. So 49, this is not distributive. Some people like to try to distribute, but what you're going to do is mess it up doing that. So exponents come first. So what I did here is I squared this. So 1/2 times 1/2 is a quarter, and that's I squared. And then negative 2 times negative 2 is positive 4. And then you have an I squared there again. So I took the I squareds and flipped them to negatives. So that's where this turns into a negative 4th. That turns into a negative 4. And then we're just multiplying this times this, whatever I get out of there, times this. All right? So this times this, that just gets me, so 4's cancel. I get a negative I from here. And if I multiply the negative I times the negative 4, I get positive 4i. So again, people think distributive property here. You're just multiplying these two, whatever you get out of there, take it times the third one. You're doing 2 at a time. Don't do all 3 at once. All right, last one here, and then we'll get rolling with the lesson. So I to the 41. if you remember when we went through these, we looked at what number closest to 41 is nicely divisible by 4. And that is a 40. So then we rewrote this out. We have I to the 40 times I to the first. Because this would get me 41. Remember exponent properties? We just add the exponents together. Right? So this is just I to the fourth 10 times. Okay? Or I to the fourth to the 10th. I to the fourth is just a 1. So this is essentially 1 to the 10th power, which is just a 1. So we don't need it. So whatever you got left over is your answer. And that's just an I. Sometimes you have to simplify. If we had an I third to the left, or I third left over, we had to simplify that one, but we didn't end up with that in this case. Okay? All right. That is your homework. So on to the lesson. So we're finishing up complex numbers in this lesson, and we're looking to graph complex numbers on a complex plane. Not too bad. So solving equations with imaginary numbers. Now you might be thinking these are going to be factoring questions, but it's simpler than that. Think about how we get the y squared by itself. All right? We're just rearranging things and solving the way you probably learned in Algebra 1 and geometry. So first step, move the 20 over. We get that. And then we got to work to get that y squared by itself. So divide by 5 on both sides. And then we end up with y squared equals negative 4. And again, when I taught this lesson before, something similar to this, I said normally you can't have something that's squared give you a negative. But with complex numbers we can. So how do we undo an exponent that's a 2? Well, we have to square root things. So we square root the left and square root the right, and we end up with y equals square root of negative 4. Now, when we square root things, when we use this, it's called the square root property, you have to add a plus or minus when you do that, because we could have a positive or negative is a square to get us this answer. So that's the property here. So don't forget your plus or minus. Every time you use the property where you're square rooting things, you got to get yourself a plus or minus in there. Okay? And then we're just simplifying the negative 4 in the square root. So we get y equals plus or minus 2i. Since we have complex numbers, we can now do that. All right? So give this one a shot real quick. If you need to pause the video, go ahead. All right, so move the 50 over. Divide by 2. And we get x squared equals negative 25. And now we're using that square root property. Okay? When you square root the 25, we got to take the I out first. So it'd be I root 25, which would turn into 5i. And don't forget, plus or minus. Okay, I probably should have put it here, but if you remember to add it in the end, that should be fine. Okay? So the next thing we're looking at is complex number equations. So this is your standard form equation, all right? If we are looking at something else, so this is a standard form equation. Your A in this scenario is a 1. Your B in this scenario is a negative 3. So you can kind of see that here. That's the 1, that's the negative 3. So we're looking at complex numbers and trying to figure out how to make them true when we have variables involved. Okay? So what you need to do is compare what's called the real part and then compare the imaginary part. And it looks worse than it actually is. All right? So if we're looking at this equation here, the 2x can be compared to the negative 14. Because that's what's considered the real part. So this must be that. So you can make a little equation, 2x equals negative 14, and then solve that for x. And you get x equals negative 7. So that would be the answer for x. If I put a negative 7 in here, I would have negative 14 plus yi, and now we got to figure out what the y is going to be. So now I compare the complex part. I don't care about the I just care about what's attached to it. I compare those. All right, and there's not a whole lot of algebra involved here. I just say y equals negative 3. And that is as simple as that. So if I put this in for the x and put that in for the y, we got the same thing on the left as we do the right. So x equals -7 and y equals -3. This would be a complex number equation. Okay? So let's look at this one. Give it a shot, see if you can figure it out. Again, if you need to pause the video, go ahead. So we compare the real part. So 3x equals 15. And then we compare the imaginary part, or the complex part. And you got -y equals 2. And then we got to do a little bit of algebra on these two. So divide this by 3, x equals 5. And then we divide this by -1, y equals -2. And you should be able to put these in here, okay? So 3 times 5 is 15 minus -2, so it would be a +2. That works out. You should be able to check these answers, okay? So that's complex number equations. A little bit of review from yesterday. We'll work through each of these. You can skip ahead if you need to, but we'll FOIL this one out. This one takes a little bit more time because remember when you have three things like this, I said one of these a little bit, or I told you about one of these a little bit ago. So remember when we have three things like this, I did one of these a little bit ago, but not like a FOIL. We have to look at the first two, FOIL these out, and then we take whatever we get out of there times my 3 plus 7i, okay? So you have to do those two at a time. So we'll come back to this one. Okay, top one, FOIL. 2i times 4, 2i times 5i. So we'll have 8i plus 10i squared. And then we got to do the inner part, so plus 12, and then the last part, plus 15i. And now we simplify this down. So remember, I squared flips whatever it's attached to a negative, or flips its sign. And then we add the real parts and the complex parts. So -10 plus 12 is a 2. 8i plus 15i is a 23i. And we're done. So just make sure you remember, fix those I squareds. All right, next one, we'll give this a shot. So 2 at a time. Multiply the -4 into both of those. So -8 plus 4i. Take the 6i into both of those. Plus 12i minus 6i squared. We'll fix this one up before we multiply it by that one. So that turns to a plus 6. And we got -8 positive 6 is a -2 plus 16i. All right, now we're going to take this one and multiply it by that. So 3 plus 7i. All right. Oops. So multiply the -2 through both of those. So -6 minus 14i. Multiply the 16 through both. Plus 48i. And then 16 times 7, 112i. All right, so remember your tricks. If you're doing 16 times 7, that's like 10 times 7 plus 6 times 7. So that's a 70 plus a 42. So that's how we get that 112. And that should be an I squared. All right, so that flips. -112, put that with the -6, so it's -118. And then put these together, so plus 34i. And then we are done. Okay, so this one took a little bit more work, but you kind of see if you do one round with these two, it turned into something that's kind of small, and then you have to take it times the other one here, which is also not that big. Okay. Application for these. So I'll show you this real quick because you're going to have it on your homework. So in an AC circuit, the voltage E, current I, and impedance Z are related by the formula E equals I times Z. Find the voltage in a circuit with a current of 1 plus 4J amps and impedance 3 minus 6J ohms. So the J is treated like an I. Okay? So voltage, find the voltage in a circuit with current that. So our current is I and impedance is Z. So we're going to plug this in for I. So 1 plus 4j. And we're going to plug this in for z. So times 3 minus 6j. And that will equal my voltage when I'm done. And then we just FOIL it out. Okay? So 3 minus 6j plus 12j minus 24j squared. And this, I said we treat like an I. So j squared will flip that, and it'll be a plus 24. And then we simplify. So 24 plus 3 is 27. Negative 6 plus 12 is a positive 6j. So that would be the statement that represents my voltage. All right? So it looks a little different. Just treat the j like an I, and you're doing the same thing. Okay, on to simplifying. So if you have an I on the bottom, that's like a square root in the bottom, and kind of remind you of when this happens. We cannot have square roots in the denominator, so what you have to do is fix it by using what's called rationalizing. Okay, so to rationalize, I multiply it by itself on top and bottom. And then we simplify from there. So this would be square root 2 over square root of 4, which is just a 2. So this would be square root 2 over 2 when I simplify that. And I can't simplify into a radical. Radicals are different than whole numbers. Okay? This is the way we've done this with real numbers. So these are complex numbers. So the problem is the I. And that is the square root of negative 1, right? So if I need to multiply out a square root, I'd multiply this by another square root of negative 1. Or I'd multiply it by just another I. So if there's just a single I down here, or a number times an I, you want to multiply top and bottom times an I, and that should fix it. All right, so let's check it out. So take both of these times that, and that would be an I squared. I times I is I squared. Down here, I'll have 2I squared. And now we need to fix all the I squareds. So that turns into a negative 1, and then that turns into a negative 1. Okay, so we'll have 5I minus 1 on top, and then a negative 2 on the bottom. Okay, this needs to be flipped around now, okay? But we're going to separate this, because we have to have it like this. It has to be two separate pieces. We have to have the real part, and we have to have the complex part. Okay? So in order to split this, if you remember how fractions work, we put a negative 2 under both of those. We divide negative 2 from both. So we're going to do the real part first. So negative 1 over negative 2 is just a half. And then we put 5I over negative 2, so that makes it minus 5 over 2I. And this is what you have to do for the answer. So this is the real part. 1/2 is my A, minus 5 over 2 is my B. You have to split it up like this to be in standard form. Okay? Every time when you're doing these, they got to have standard form. Okay? So give this one a shot here. Pause the video if you need to. Otherwise, we'll keep rolling. So times this by an I, times this by an I. And that goes through. So my numerator, 2I minus 3I squared. Denominator, 2I squared. Flip my I squareds. So this turns into 2I plus 3 over negative 2. And then we split it. So we have to have standard form. Do the real part. So negative 3 over 2. Do the complex part. So here is where you're going to have to simplify a little bit. So 2 over 2 is a 1. So this would just be minus 1I or minus I. You don't need the 1 there. Okay? So when we have just a single I or a single term in the bottom, you're going to multiply by an I. When we have more than one thing in the bottom, that makes it a little bit different. Okay? So when we have more than one thing in the bottom, it will look like this. We have to use what's called the complex conjugates to simplify this one. Okay? So if you have A plus BI, then A minus BI is its conjugate. With something like this, when we're working with complex numbers, you have 3 plus 2I on the bottom. So it's a little more complicated than the last one. So we have to use what's called the conjugates. So that's the same exact numbers, but change the sign in the middle. So when we use that, it'd be 3 minus 2I in the top and bottom that we have to multiply by. Okay, so we'll have to FOIL on the bottom, distribute on the top, and then simplify from there. So take that through, 15i minus 10i squared. And then the denominator, FOIL this out. So 3 times 3 is 9, minus 6i plus 6i minus 4i squared. And then from here, simplify everything out. So we see those cancel out. And then we can fix our I squared. So that would turn to a plus 10. This down here would be a plus 4. And then we'll rewrite this fraction. So 15i plus 10 in the top. And the bottom would be a 13. All right. So just like the last ones, remember we have to write things in standard form. So we got to have that a plus bi. So we split up the real part first, and then we go to the complex part. So 10 over 13 is the real part, and then 15 over 13 with that I is the complex part. Okay? So that's how we multiply using conjugates. All right, so over here, we're going to do the same thing. The top will be a little more difficult because we have the 7 plus 5i and not just an i. So think about what is the conjugate of 1 minus 4i. That would be a 1 plus 4i. Okay, we have to do that on the top and the bottom. So we're going to FOIL on the top. And then FOIL on the bottom. So the top will have 7 plus 28i plus 5i plus 20i squared. In the bottom, we'll have 1 plus 4i minus 16i squared. And then just like the last one, we look to simplify. So the 4i and negative 4i are going to cancel. And then we'll have a negative 20 from that and a positive 16 from that. And let's simplify and rewrite this out a little bit. Okay, so numerator, let's just do the real part right away. 7 minus 20, we get negative 13. And then 28 plus 5, we get a 33i. And then down here, we got 1 plus 16, that would be a 17. Okay, so double check your math. 7, 28, 5, 20. And then we split this up. So we do the real part, then the complex part. So negative 13 over 17 plus 33 over 17i. And then you're done. So that's how you simplify using conjugates. All right? So remember, the bottom is the only thing you need to look for when you're thinking about conjugates, because the top, we can have square roots in a numerator, we can't have square roots in a denominator, and that I is a square root. Okay? So a couple more practice questions. If you're good to go ahead and skip ahead, if you would like to see these, I'll work through these here for you. So this one, we need to use conjugates because we have 1 plus I, so we have to use the conjugate 1 minus I. So distribute on the top, FOIL on the bottom. Okay, we get 1 minus I plus I minus I squared. Cancel out your i's, simplify the I squareds. Plus 3 plus 1, because that's just a 1i squared, and then rewrite the fractions. So 3i plus 3 in the numerator, 2 on the bottom, and then we need to split this up. So real part, then complex part. So this turns into 3 over 2 plus 3 over 2 with an I on the side. Okay, that would be what we get for that one. So this is standard form again. We got the A plus BI. All right, looking at this one, that's back to one of the easier ones. The only thing that's causing the problem here is the I. So we don't have to use conjugates. This is where you just multiply top and bottom by an I. And you'll have to distribute on the top and just multiply on the bottom. So our next step would look like this. We got 3i because it's going here. And then we're going here. So 3i plus 2i squared. And then the denominator, we'd have just a 2i squared. And now don't look to cancel those. We're just going to simplify these I squareds. So it'll be a -2 here and a -2 there. And now we can split it. So let me rewrite it for you a little bit better here before I can show you how to split it. So do the real part, -2 over 2, that's a 1, and then 3 over -2. So that should be a minus. Let's get rid of that plus here. That should be a minus 3 over 2i. And there you have it. So that's how we simplify complex numbers with i's in a denominator. All right. So next thing we want to look at is graphing. All right. So this is the normal axis that everyone's used to working with. This is the complex axis. So we have, or complex plane, excuse me. We have the real axis, which is like the x-axis. We have the complex or imaginary axis going up and down. That's like the y. So if you compare this point to this point, hopefully you can kind of put together that they are pretty much the same thing, except this is in that a plus bi format, and this is just an x comma y. So you can kind of treat the x like the a and the y like the b. Okay, so here's a few more examples here to check out. This one would be like a 2, -1, but it's written as 2 minus I. This would be like a 4, -2, but it's written as 4 minus 2i. So you have to be able to switch your brain to think about these complex numbers like these regular numbers. And you have to write them as a complex number. Okay? Let's look and see how to graph a few of these. So think about what coordinate this one would be compared to. So this would be like a 3, 4. That's 3 and +4. So we'll go 3 right, 4 up, and then that would be our point. Okay? And then we're done with that one. Okay? So this one would be left 2, down 5. Left 2, down 5, and we're here. Okay, and it's good habit just to label them. It looks like a 51, it's an I. Okay, it's good habit to label them, and I'll show you in a little bit why. This one might be a little tricky. Just think about what's the real part, what's the complex part. So this can be written like 0 plus 7i. That's the same thing. So I'm not going to go left or right at all. I'm just going to go 7 up. So we go 3, 6, 7 right there. And you just write that as 7i. Okay? I'll do this last one. So 4 right, 1 up. And that is our 4 plus I. Okay? So hopefully that kind of makes sense. You're just graphing these like normal. So what we're actually doing here is we're graphing vectors. So I'm going to use this one here to kind of show you what I mean. So a vector is essentially a ray out from the center or the origin to the coordinate that you listed or that we drew. So a vector will have an x component, this, and a y component, that. All right, and so I'll show you what I mean. So the x component, if we look at this, kind of hard to see that blue ink. How far left and right did we go here? So that's 3, and then we're going up 4 units. All right, so you can kind of see we can make a right triangle with these components. This is my real part. This is my complex part. So that's our a plus bi. So we don't necessarily need the I with these because it might mess us up for the next step. But think about right triangle geometry. How do we find this value? Well, we have to use Pythagorean's theorem if we have a right triangle. So this value, what we're looking to calculate, I like to call the magnitude. Okay. However, our textbook will call this the absolute value. And so that's what we're looking at next. All right. So the magnitude or absolute value of a complex number. So remember, these are like vector components, and this is like our x component and our y component, and we're trying to find the hypotenuse essentially. So this is my a, this is my b. We don't care about the I when we're doing these. All right, I just need to know the a and the b. And we're going to use Pythagorean's theorem, which is this formula given to us here. All right, so I'll just show you that quick. If I got this, solving for c, square root both sides. C equals square root a squared plus b squared. That's Pythagorean's theorem. So we're plugging in the -6 and the 3, and we see what we get. So -6 squared plus 3 squared, that's all under the square root. So that would be square root of 36 plus 9, and we end up getting square root of 45. And we don't want to leave this like that. We got to simplify, okay? We need to get this in simplest form. We'll leave it exact, but we want to simplify it. So how do we simplify radicals, factor trees? So we got a 5, a 9, and the 9 breaks down into a pair of 3s. So we'll take that pair of 3s to bring it out in front, and we will have 3 square root 5. So that is the magnitude or absolute value for this complex number. Okay? And what a lot of people like to do that messes them up is they like to use the I. A reminder, you're not using that. That just tells me that this is my B right here. And then we just plug it in our Pythagorean theorem. Okay? One more of those. So if you need to write it out completely, the A plus BI, I don't have a real part here. This is just complex. So we have 0 plus 6I. And then we're going to use our formula. So square root 0 squared plus 6 squared. And hopefully you see this one is kind of easy. 0 doesn't make a difference. So we got 6 squared. That's a square root of 36, which is just a 6. So 6 is the magnitude of our vector, or the absolute value of our complex number. All right. So show you one more way to do things with these. So we're going to simplify these by graphing. In the last lesson, we learned to just add these like normal. Okay, so I'll show you that first. So parentheses don't really make a difference when we're adding. So 3 plus 2, that's a 5. And then we add the complex parts, 5i plus negative 4i. That'd be a positive 1i, or just an I. So I'm going to show you how to get this graphically using what's called vector addition, or in this case, vector subtraction. So we have to do tip-to-tail method, which is a fancy way to say we do this one, and then after we graph this one, we do this one from that point. So we go 3 right, 5 up. Okay, that's our first complex number. And now treat this like the new origin. So now we're going to do the other point from here. So you go 2 right, 4 down, and we're here. And whatever point you land at here, that would be your answer. And if you look at this, we go 1, 2, 3, 4, 5 right, 1 up. That is 5 plus 1i, which is exactly what we got when we did it the normal way. Okay? If I'm showing graphically that's the answer, this is what we got to have. Okay, we show our first vector, second vector, done. All right, so that's the solution. For subtraction, it works the same way as what we did before. You first distribute the negative, and we're going to rewrite this one. So this would be negative 3 plus 7i. So now we're going to do this one plus this one for our tip-to-tail method. So 4 right, 6 down. 4 right and 6 down. We are here. Okay, and I'll draw that arrow going out to that. And then here's our tip. Now we have to do the other one. So we go 1, 2, 3 left. 1, 2, 3, 4, 5, 6, 7 up. And we finish out right there. Let me draw that arrow to that one. And that is 1 plus 1i for that final point. Okay, and if we go back here, look at this. 4 minus 3, 1. Negative 6 plus 7, positive 1i. You get the same thing. Okay? If you're told to do it graphically, this is what we got to see. All right? So hopefully you picked up some new concepts with complex numbers. Here is the assignment for the lesson, and feel free to go back and look at any examples. If any of them are still a little confusing, send me an email and we'll get it taken care of. Thanks for watching.